Okay, so the first question was 194 divided by our 54753. So when we're looking at 194, again, if we're going to use like the big chunk method that we basically talked about just now, then we're going to look at how many times 194 can go into like each individual digit. So 194 can't go into 5, right? Because like 5 is too small. And 194 can't go into 54 because again, that's too small. So the answer key here, the way that it showcases it is like basically it writes zeros along the side. So it will write like 0 here, and it'll bring down 5 and 4. Then it'll add another 0, and it'll bring down 5, 4, and 7. So basically this notation basically just showcases that we're taking more chunks, right? We're taking more bigger numbers. So you'd have to actually like do the math for this, but it shows that, again, if you want to use kind of like the rounding method, we can think of 194 as kind of equivalent to 200, like if we're rounding it down. And rounding it up, sorry. And 547 is close to 500 if we're going to round it up. So 200 can go into 500 like 2 times, right? So then we can kind of like estimate that like 194 will go into 547 2 times. And when we actually do the math for that, we do like 194 times 2. Again, if we're going to use our distributive property, then it's going to be 2 times 100 plus 90 plus 4, which is the same thing as 200 plus 180 plus 8. So basically their answer is like 388. So we're going to put our 2 here, and we're going to subtract 388 from this. And then you have to do like your subtraction from that, and you should get like 159 as your answer for here. And then now you can bring down this 5. And when we bring down our 5, again, the reason why is because we still need bigger chunks. Like 159 can't go into like 194, so we need to make it like into a bigger number. And so this time, okay, we need to like round again to see what the closest number you get. So if we're going to say like 194 again is close to 200, then we can say, I have to erase all this. 194 is close to 200. And let's say that like 1595 95 is close to like 1600, right? Then you can kind of see like 200 could go into 800 like 8 times. So we're just rounding up both numbers. And so we can estimate that like maybe this would be 8. And we can actually see that that actually works out right. So we do 194 times our 8, right? Using distributive property, it's the same thing as saying 8 times 100 plus 90 plus 4. Then we multiply an 8 for each time. So we get 800 plus 720 plus, that'd be 32. Yeah, so you get 1552 as like the result of this. So now you have to subtract this 1595 from 1552. So then you would get your result here as like 433. So yeah, I need some more space for this, but so far it kind of makes sense, right? Because we're still doing like the chunk method where we're looking at bigger pieces of your number, and we have to keep on like bringing down values so that 194, which is a big number in itself, goes in. And you can see like the bigger chunks that we're using, we have like less steps, and that the end result also becomes like significantly smaller. So I'm going to create another page and continue doing the math that we just did right here. And so, like a continuation of the math that we just did now. So we subtracted 547 from 388. So it gets 1595 minus 1552. So now we got to our 443. Again, this 3 being brought down from here. So this is basically where we left off. And so now, again, rounding. So we can know that 194 will go into 443. So 194 is again equivalent to 200. And we could say 443, if we round it down, is equivalent to 400. So it'd basically just be 282. So then when we actually do the math for this, 194 times 2, same thing as saying 2 times 100 plus 90 plus 4. Then our answer is 200 plus 180 plus 8. So that basically gets us as 388. Subtract those values together, and we get 45 as our remainder. So 882 should be your answer, and then 45 should be your remainder for question number 1. So I hope that this writing it out kind of shows you, even for really complicated problems, the kind of benefits of doing the big chunk method, why the distributive property even works for multiplication, the importance of looking at how many basically steps that we used, the more times we looked at bigger portions of our number, and also kind of what the remainder even looks like for a question like this. So I'll do the second question as well. And again, stop me if you guys have any questions while we write this out. But I'm hoping that this kind of lets everything make more sense as we continue to go on. So new page. So the next question that we had, again, this is another remainder question. So this is the more complicated ones. But we're doing 162 divided by, we're doing 162 divided by 61,571. So again, we're going to use the methods that we just learned about. So we know that 162 can't go into just the number 6. So we're going to write a 0, bring down our 6 and our 1. 162 can't go into 61. So again, we bring down another 0. So we can bring down 6, 1, and 5. Now we got something that kind of makes sense. So 162, we can kind of round it as being 200. So 162, close enough to getting us to our 200. And then 615, that's close enough to us getting to our 600. So 200 can go into 600 3 times. So we can write out our 3 over here. So we can do 162 times 3. So 162 times 3. Use our distributive property. So 100 plus 60 plus 2 times our 3. So then we get 300 plus 180 plus 6. So that should get us 486. So now we can subtract 615 from 486. If you do the math for that, you should be getting 129. And now we can bring down the 7 from all the way over here, because again, 129 is too small for 162 to go inside of it. So we bring out our 7. And again, we do the same process. Look at what 1297 could be rounded to, and then look at what 162 could be rounded to. So 162, we're going to say close enough to 200 again. And this time, we can say 1297. If we wanted to, we could say it's close enough to 1300. So this number could be anywhere between 6 to 7.5, right? Because technically it should be 200 times 6.5, 6 to 6.5. But if you actually did the math for this, then you would realize that the number should actually be 8. So the kind of thing is the rounding method doesn't always work out, but what it does tell you is that it should be somewhere near 6. So you're never going to go beneath 6, and you're probably going to be somewhere higher than 6. So just for purposes of speed, I'm going to just assume that we already know it's 8. But what you would do is after this, you figure out that okay, 6 doesn't work for 162 and to get us to this number, so you basically try every number after that. So you would try 6, you try 7, you try 8, and then you figure out that 8 is basically the number that you'd want. But yeah, the estimation, either 100% gets it to you, or if not 100%, at least again, it's an estimation. So you get somewhere nearer to that value. So we get to our 8 value. So we can do 162. Now we have to multiply that by 8. So that's going to be the same thing as writing out 8 times 100 plus 60 plus 2. So that's 800 plus 480 plus 16. So 1296. And that's actually super close to this 1297 that we have here. So we get our 1. And now we can bring down, finally, 1 doesn't go into 162, so we will have to bring down our extra 1. But 162 doesn't go into 11 either. Now, something that I need to note here is that you do have to put a 0 because it's not just 38. And the reason that the 0 even exists in the first place is because once we see that like 162 can't go into 11, obviously we know we're going to have a remainder. 11 is going to be our remainder. Obviously we might use like our decimal places. But a 0 exists in the first place because we are bringing down 11 completely. So 11 is what's going to be like how we did over here, where we brought down the zeros every time we brought down a number. Well, we didn't have to do that before because each time we were able to eventually get that number into our value. But in this case, this 11 can't go into it anymore. So we would have to add our 0, then our decimal point to continue on with our decimals, or to have a remainder. But if you don't want to do it, then your answer would just be like 380 remainder of 11. So this was definitely a much more like trickier problem than the one before, but still the same rules apply. You can still use estimation, but it's not going to get you the answer 100% of the time. But it gets you somewhere like nearer to what you actually need to do. Instead of like starting all the way from 1 and 10, you at least get to 6, so you can get to 8. And then also whenever you're doing like the subtraction values, you have to keep note of like, even if 11 is a remainder, well, do I add another 0 or do I add a decimal place? So that's like an important distinction to make. So again, these are the more complicated problems, but I hope for those of you that did try and like challenge yourself that this makes much more sense, kind of like the applications. So I'm going to stop here for questions before we go on to the easier problems. If everyone could just like give me a thumbs up if it makes sense, or if it doesn't, then like ask your questions to the chat now before. Okay, great. So I'm getting a lot of thumbs up. Okay, wonderful. So I guess we're going to start on to the easier questions. So these are the ones, I know number 3 especially people are saying they have trouble with. So let's see like what that has to do with our answer. So the question was 38. Oops. The question was 38 divided by 817152. Okay, so a lot of people were saying that we were supposed to get our remainder here, but like the math that shows up doesn't really get us to that point. So we'll see like kind of like maybe where the mistakes are made. So here again, the first value is 8. So we can't just look at 8. We have to get a bigger chunk, a bigger portion of our number, because 38 doesn't go into 8, but 38 can go into 81. How many times? Well, let's do the rounding again. 38 can round to 40, and 81 can like round to 80. So 40 goes into 80 like 2 times, let's say, right? So if we put a 2 here, then we realize that 38 times 2, well, it's the same thing as 2 times 30 plus 8. So that gets us 60 plus 16, so that gets us 76. So that's pretty close to our 81. So we don't have to worry about estimating it even farther. So we can just do 81 minus 76. So 81 minus 76 gets us 57. And then now again, we have to do the same thing. Round our 57, I guess you could say, into 60 if you wanted to. So 57 would be close to 60. And then 38 would get you close to 40. So yeah, someone did put like a 1 already. But before we get like ahead of ourselves and like why that 1 would even exist in the first place, again, I want to showcase like why sometimes the estimation wouldn't work, because we already kind of know that 38 times 2 we get a 76. So obviously if we multiply anything by 38 that's greater than 2, then it's going to be too big. So instead we're going to multiply 38 by just that 1 here. And you can even kind of see it here with the estimation, like 40 times 2 would be 80, and that's too big to go into our 60. So again, you'd only focus on that 1. So when we actually do that, we're going to do 57 minus 38. And so that gets us the value of 19. So we can bring our 1 down, because again, 38 can't go into 19, but it can go into 191. And let's round it again. So 38 is close enough to 40. And 191 is close enough to 200. So 40 can go into 200 like 5 times. So that's what gets us the value of 5 over here. So what we can do is now multiply 38 by 5, see how many times it does get into that value. So 5 times 30 plus 8, so we get 150 plus 40, and that's really close. We got now like 190. So that's really close to that value here. So you can bring that down. We have our 1, so we have 215 we bring down our 5, right? But 38 cannot go into 15, that's still too small. So this time we have to actually bring a 0 again, because we are bringing down even more numbers. So we bring down 152, and now, again, rounding. So 38 becomes 40, 152, you can think of it as like 150. So 40 can either go into this like 3 or 4 times. You can try out the math for yourself on both. The correct answer is 4. So when you do that math out, then it should have gotten you exactly as 152, because that would get you your 0. So there would be no remainder, basically. So if you want to try out the math for 4 specifically, you would do 30 plus 8 times 4, so that's 120 plus 32, so that gets you your 152. So our answer would basically be 21,504. So does that make sense? There is no remainder, but this is the answer that you should have gotten. I'm just going to check the question chat to see that there's no questions. Again, like thumbs up if this is making sense. This is the easier question, so this is hopefully something that should just be reviewed. Okay, great. So we got a thumbs up here. And finally, very last question. Thank you guys for everyone's doing the thumbs up. That's great for the participation. Very last question here is going to be basically our big crazy number, our 9, 6, 5, 4, 2, 1 divided by 3. And what I wanted to show specifically with like this kind of question was the importance of actually looking at these questions in terms of like groupings. And in this case, we only have like one type of grouping. So we're looking at the grouping for only like this one question instead of like these greater parts. Like, sorry, one digit instead of like these greater parts. Because 3 can go into 9. So we know 3 can go into 9 like 3 times. So obviously, you round down your 9, so you're pretty good. Now you have your 6, right? 3 can go into 6 2 times. Somebody wrote that already. So we get down to our 0, then we get our 54. Actually, not even 54. So see, I'm even getting ahead of myself. Because again, this is just a single digit, and this single digit can go into like a majority of these numbers. So someone put down a 1. So we put down a 3. So we get our 20. Now we get like our 2, but 3 can't go into 2. So we do have to bring down a 4. So someone put our 8 up there. So we have our 24, and we get our 0. Now we bring down our 2. But okay, someone did put a 0, but why would we even want a 0 in the first place? Again, think about it. We were able to bring down this 2, but we also have to bring down another value of 1. So again, whenever you're bringing down like multiple things at once, you'll always put down your 0. And so because we're bringing down both 2 and 1, then we have to add that 0 over there, and we get our 21. So subtracting that 21 from there, then we get 21 minus 21, which at the end of the day is just 0. So yeah, someone else also put 7. So our answer would basically be this. So again, even this question doesn't have a remainder, but what I want to show specifically with this is that you have a lot more steps. So like let's say 1, 2, 3, 4 steps, actually 5 steps. And that's because you are dividing a 1-digit number by this really big number, and the portions that you're using are going to be smaller because 3 can go into each individual digit compared to a bigger number like the one that we had before, like 38, for example, which was even less steps. And so the final value and the final steps that you did was even less as well. So I hope this makes sense. This was like our division review. We kind of did it for an hour, but I hope like this kind of estimation estimation kind of process, and then also the distributive property that we implemented makes a lot more sense when it comes to looking at these kinds of practice problems and how you can use them for both remainder kind of questions and even like simpler questions where it's easily divisible.